What is the work to be done to increase the velocity of a car from 30 km per hour, that's good, to 60 km per hour if the mass is so many kgs? So things are clear with units, no conversion is required. So we can directly write the given in form of a diagram and be done with it. So we have an object having some initial velocity, and we apply some force and its velocity increases a lot. Not a lot, but with some amount. So we have this object to be of 15,000 kg, not 15,000, 1,500 kg. The initial velocity is 30 km per hour, that's good. And the final velocity is 60 km per hour. Right, it's a simple straightforward question. Conceptually, if you know a few things, you are pretty much done. So with the working, what is that we're looking at? We're looking at work done to increase the velocity is equal to change in kinetic energy. Change in kinetic energy. Right? How do you figure out the change in a kinetic energy? All you have to do is subtract final and initial kinetic energy. Okay. So, but kinetic energy is what? We know that kinetic energy is half mv square. Mv square by 2, if not half mv square. If I substitute this, what happens? We have this to be equal to half of m initial velocity square minus half of final velocity square. What is common between all of this? See, now the trick here is, how do you handle the calculation? Should I go with that substitution, squaring and all of this? No. You need to learn the alternative. I'm going to take half of m common, and we have v square minus u square. And now we're going to use one particular formula, a square minus b square. Why? It's of this form. Can you see that? What is a square minus b square, guys? Yes, a plus b into, yes, a minus b. Okay, so we're going to expand it, right? And in our head, we're going to substitute things. So half of mass is 15,000 and v plus u is 90. V minus u is 30. Yes, I've done it directly and it's okay to do directly. 1s are 15s are. So 15 into 15 is 22500 into 9. What I'm going to do is I'll put all the zeros at one place. So this is 10 to the power of 3. So 225 into 9 is nothing but, I'm going to show you guys the calculation over here. So this is what I would like you guys to do. Into 10 minus 1. You need not write this in your exam. All you have to do is this. Right? I wrote 9 as 10 minus 1. 2250 minus 225. Is it not? I use distributive property basically. 5. No, yeah, 5. This is 4. So this is 2. This is 0. So this is basically 2025 into 10 to the power of 3 joule. That's it. So you learn to do the calculation this way. See, I hardly did any multiplication. It's all a bit of cancellation over here and subtraction. That's it. So this is the whole funda. It's not about solving the question itself. It's how you get smarter with different difficult scenarios. How do you make use of different knowledge that you have learned across the years? Whatever you're learning now, whatever you learn in previous grades, all has to be combined. It's not only that, okay, this is a syllabus and I'm going to mug this formula and I'm done. Please don't do that. Okay, please pause and have a look at the answer.